This video will discuss the enthalpy of reaction in thermodynamics. So for most chemical reactions, as I've been saying throughout this chapter, the pressure does not change during the reaction. For most reactions, they occur exposed to some external environment. That external environment often has, if it's just the atmosphere, is about a pressure of 1 bar or 1 atmosphere, and doesn't change much during that chemical reaction. So for most chemical reactions, things that are exposed to the external environment, the pressure is virtually constant during that process. So we've defined enthalpy in previous videos, which is an extensive state function. The enthalpy is the internal energy plus pressure times volume. We now define the enthalpy of reaction, deltaRh, as we would say there. Delta being change, R for reaction, and H being enthalpy. So we have the enthalpy of reaction, which we're defining. The enthalpy of reaction is equal to the enthalpy of the products of the reaction minus the enthalpy of the reactants of the reaction. So if the enthalpy of the products is greater than the enthalpy of the reactants, then the enthalpy of reaction is greater than 0. If the enthalpy of the products is lower than the enthalpy of the reactants, then the enthalpy of reaction is less than 0. When the enthalpy of reaction is greater than 0, then heat is absorbed into the system. At constant pressure, the heat absorbed is that enthalpy of reaction, and we would say that that is an endothermic process. Endo being taken into, therm, heat. So we're taking heat into the system from the surroundings and increasing our enthalpy, increasing our internal energy. All right, when we have the enthalpy of reaction less than 0, heat is released from the system to the surroundings. So that is an exothermic reaction. Exo, out, thermic, heat. So we are pushing heat out from the system to the surroundings, decreasing the enthalpy of our system, decreasing our energy because we are pushing out that energy to the surroundings as heat. And as I mentioned, that the enthalpy of reaction is equal to the heat of reaction at constant pressure. Okay, we can also define the quantity, the standard molar enthalpy of reaction, where the molar enthalpy is a state function. So the molar enthalpy of reaction is an intensive state function. So it is per mole of reagent. So deltaH of reaction per mole of specified reagent, and then the extra caveat that it is at standard conditions, which is what is indicated by this kind of circle up in the superscript circle up in the top right. Anytime you see a superscript like that in the top right for a circle or a 0 or an O, that is indicating that it is at standard conditions. So there's some standard state that is in reference to. So various standard states exist. There's standard temperature and pressure, STP, which is a pressure of 1 bar and a temperature of 273.15 Kelvin, or 0 Celsius. Standard atmospheric temperature and pressure, SATP, 1 bar and 298.15 Kelvin, 25 Celsius. Then there's also normal temperature and pressure, which you might encounter as 1 atmosphere of pressure and 293.15 Kelvin, 20 Celsius. So just pay attention to if your particular professor or whatever you're working off of defines a specific standard state for your enthalpy, that you make the correct choice there. Mostly the standard state for our purposes is going to imply 1 bar. And if I don't specify a temperature, pay attention to whether that's going to be 293 or 298 Kelvin. Sometimes between physicists and chemists, the standard state differs as far as what they call the standard temperature. But mostly 1 bar is the point that we want to make sure we're clear on for the pressure there. So this is the enthalpy of reaction. So an extensive state function, when its sign determines the heat that is either absorbed or released during the process, telling us whether it is an endothermic or exothermic reaction. At constant pressure, the enthalpy is the heat of reaction, and we have our standard molar enthalpy telling us the enthalpy change per mole of a specified reagent at our standard conditions.